Hey, hello, Miss Terry's here. How's everybody doing? Let's get ready to learn some more math. How about multiplying polynomials? Okay, so multiplying polynomials. The background knowledge that you need for multiplying polynomials is the product rule for exponents. So basically all that says that if your bases are the same, then we will be adding. Exponents are added for product rule. First thing with product rule is monomials times polys. There's nothing, no easy way to do this. The only way really to do this is by distributive property. Outside times everything inside. I have number 1 and 6 on the screen for you. So it's just outside times each term. So you can see here how we added exponents, 3x, 2x, 6x squared. So here we got monomials times polys. Monos times polys. Mono means one term. Polys mean 2 or more. Don't forget integer rules. Negative times a negative is a positive. Negative 4 times negative 12 is positive 48. Like terms, there's a hint up top if you have forgotten that. Like terms have the same letter and same power. We'll head over to the next part. What is box method? Okay, what is box method? Box method will work for any of them, not just for a 2x2, works for any of them. FOIL only works for buys, buy times buy, but the box method will work for any one of them. You can see buy right there. You can also see where I've set up a buy times a try. This would be a binomial times a trinomial, 3 terms. It's a 2x3. 2x3. There's a 3x3. So you draw the dimensions of what you have. You're going to write your polys across the top and the left. Polys will go across the top and left. We're going to multiply to fill in the boxes. We're going to mark our diagonals with circles or arrows because most of the time, unless you have more than one letter or they're advanced, your diagonals will be your like terms. Then you're going to add everything that's in the circles, and then you're going to bring over the guys that are by themselves. So you can see the blue is where I did the diagonals, and then the circles are the guys that ended up by themselves. So if you want to take a picture of this, your screen has refreshed when you see the square in the bottom right, or star in the bottom right. Start with buy times buys. These are all here. I'll start at the top, 1 and 2. You'll see there is the 8, the x plus 8, x minus 2. Put the sign with the number. You see, I put my plus and my minus over there because it helps you when you are multiplying these things. So you see my arrows point to it. I multiply to fill in. Multiply to fill in. So if you look at all the boxes on the inside, you can see where I go up and left to fill in the boxes. So just look at those. You'll see where all of that came from. We have a difference of squares at the bottom, a plus and a minus. Do it the same way. There's a perfect square trinomial. You'll see it written squared, but all you need to do is just write it out twice. So we multiplied filled in. Circle your diagonals or make arrows because those are the ones that go together. The guys that are by themselves, bring down. The -6 is by itself. And the ones that are in the circle, you add. So you add the circles. Multiply to fill in, add the circles. When you see the star, your screen has refreshed. Go ahead and get your pictures. Take note of opposites. I hope y'all know what opposites are, because if you have two things that are identical and they're just different signs, they're gone. That is 0. So you'll see in this answer right here, there's no middle term. Opposites are 0. We got a by times a try. So I cannot use FOIL. Won't work. FOIL, first, outer, inner, last. So you would have to do distributive property 1, 2, 3, 4, 5, 6. There'd be 6 things. There'd be a lot. Then you'd have to come down here and say, oh, these two are like terms. Oh, okay, these two are like terms. It could be that you didn't even see that guy. So in other words, there's margin for error. Margin for error. There's not margin for error when you use box method, because the box lines it up very nicely for you. I wrote my polys across the top and left. Now I'm ready to multiply to fill in. 3x cubed, I'll go ahead and fill that in quickly. 5x squared, negative 6x, go up and over, up and over, up and over. 5x, and notice I'm putting my signs. Why am I doing that? Because when I put my diagonals together, my sign is right there with it, so it makes it faster for me to add it. You see, I've got my guys that are alone. I usually circle them because they're alone. And then you're done. You're now ready to write your answer. The guys that are alone bring down, and the circles add them because they are like terms. And boom, you're done. It's a whole lot faster than trying to find your like terms, you know, because if it could get very long. I'll fill this one out. You'll see, it's a 2 by 3. Put my signs with the number. Put my signs with the number so you don't forget anything when you're multiplying on the inside. The signs are important. You'll miss it, remember. So we've got a negative 12 cubed. That's a positive 3x squared. A positive 24x. That's a positive 8x squared. Negative 2x and negative 16. Diagonals go together. And my guys alone just carry over. So carry over my guys alone and add my guys with circles. That's a plus minus, I got to subtract, plus 22x. And I am done. Obviously, it's faster. Do y'all agree it's faster? Go ahead and get you a screenshot if you want one.
It's easier.
Yeah. If you come from where somebody might have told you that you are learning disabled math, or maybe you're learning disabled reading, you know, or maybe you've had somebody that's told you that you're dyslexic. You know, dyslexic does not mean you write things backwards. It means that processing between vision and your brain, it flips it. I mean, some people think it's writing it backwards. It's not. You know, it's not just that. It's processing between eyes and brain is dyslexic. So if you happen to be one of these people, you can see how the box method is perfect for those people, because it breaks it down. It puts it, you know, easy. You've got your diagonals together. Visually, everything is together instead of trying to deal with all of this at the bottom. Like, that's a lot, because you know those things can get real long. I've seen students do distributive property and actually have to go to line 2 because they ran out of paper. And then it's real easy to forget like terms when you have that long thing out there. Not in this case. I'll show you intense version. This version right here is what I do in class with the students. I ask, who is the smartest person in this room? that knows their stuff, like knows exponent, knows positive, negative, like they know their integer rules. I say, okay, let's come to the board and see who can do it faster. And I prove to them that box method is faster. I've never had anybody beat me. There's videos of it. They're on my YouTube channel, some of them, because we take videos. They're of Miles College students, some of them. And they try to beat me, but they can't, because I can prove to them that the box method is faster. And I will show you that it works for any of them. This is a 3x3, by the way. You would never want to do this one with distributed property. It'd be way too long, and you might leave something out. I'm really, really careful about putting my signs so that when I multiply on the inside, I don't miss a sign. So just write them out, and you'll see I'll just fill in. And I obviously can go a lot faster than that student beside me. Even though I do pick I say, who can do this the fastest, they think, because obviously some students aren't good at this anyway. They're not good at integers. They don't even know a positive and a negative is a negative. They don't know their integer rules. I hope somebody's checking me. Hope I'm not making a mistake. and same thing, it does work. It does work. Diagonals are your like terms. And then you see your two guys that are alone. So your two guys that are alone, you just bring them over. They're already ready. I got a negative 24 down here at the end. 6 and 2 is 8. That's two negatives. Two negatives together make a positive, so that's negative 10x. I'm saving this one for last because there's 3 things. I've got an 18 minus 2. That gives me 16. And then plus the 8. Yeah, it's a positive 8. So that is 24. And done. I just did a try times a try pretty quickly. Pretty quickly. There's no way you could have done that distributed method that fast. And there's my star because I am done. I heard your camera.
Oh, yeah, I forgot I have a mute.
Yeah, you're fine. We're supposed to stay unmuted in class so we can all discuss is what really how it's supposed to work. Let me get this back. So what y'all think, the people that stayed back to look at it? Did you learn something new that you liked that you've never seen before?
How you get negative 12x?
Did I make a mistake?
I'm just asking how you did it. I'm like, what?
The negative 12. Oh my God, you're right. It's wrong. That's what I was telling y'all. I said, hey, did I make a mistake? Because 3 times 2 is 6. So that was an error. Do you see where that came from now?
Yes, man. I was like, how you get 12? I was like, maybe she knows something I don't. You know what I'm saying?
Well, maybe your teacher was just having a dull moment because for some reason I thought 3 times 2 was 12. That honestly was the reason for that. That was a mistake. Good catch right there. That's a good catch. I hope there's not any more. So you guys like it? Have you ever seen it before?
No, I've never seen it before.
Never seen it either.
It's new for me.
Don't you think that when you guys learn multiplication of polys, it's first introduced in pre-algebra? Most of y'all take that in the 7th or 8th grade. Don't you think that if a teacher taught it this way from the beginning, it might make the process a little easier?
Absolutely.
Yeah. And they teach multiplication of whole numbers using window pane. You've heard of the window method. Everybody look at the window. You might have seen that before. So it's a spin off of that. It's a spin off of the window method with multiplying of whole numbers. I loved it. It was somebody that hired me at my tutoring center, and they were going to a private school in Alabama, and they showed me this. I had never seen it before. I never saw it when I went to college. I was never taught it. I actually just learned this method probably about 6 years ago. And so when I saw it, I was like, show me that again. And I tested it. You know, the girl told me it works. My teacher told me it works. And so when I saw it, I was like, wow, this is the way I'm going to teach multiplying polynomials from now on. And I never went back to distributive method, never, because I think this is better. Way to go, guys. You just learned something new that you already knew how to do. I just made it more effective and faster for you. You agree? Woo woo. Thank you for coming. I see that the time has gone a little bit over, but I tried to finish right when class ended. We just kind of chit-chatting now.
Thank you so much, Ms. Devyn.
Yeah. Any other questions? Go ahead and stop the Zoom.